All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 9.3, which is geometric sequences and series. So I'm on page 634 of the textbook, and we're going to talk about the definition of a geometric sequence. So a sequence, a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 a sub n, and we can put a dot, dot, dot after that too. Doesn't matter if it's infinite or finite. A sequence is identified as geometric if the ratio of a sub 2 to a sub 1 is the same as the ratio of a sub 3 to a sub 2, is the same as the ratio of a sub 4 to a sub 3, is the same as the ratio of a sub n to a sub n minus 1, the term before it. So, sorry, I must have smeared the stuff a little. We'll survive. And that ratio is called R, which stands for the common ratio. So what we mean by that is the short version here is that what you're doing is multiplying some R. So you do a sub 1 times r, and that's how you get a sub 2. And then you multiply by r, and you get a sub 3. And then you multiply by r, and you get a sub 4. And then you multiply by r to get a sub 5. So, for example, 2, 4, 8, 16, 32 is a geometric sequence with r being 2, because if I multiply 2 times 2, I get 4. And if I multiply by 2 again, I get 8. And if I multiply by 2 again, I get 16. And if I multiply by 2 again, I get 32, right? Now you can find that ratio by doing 4 over 2, or 8 over 4, or 16 over 8, or 32 over 16, right? So that's my r is 2. And again, if you need to find it, if you need like a more concrete mathematical way to find it, it would be 4 over 2, which is the same as 8 over 4, which is the same as 16 over 8, which is the same as 32 over 16, which is a 2, right? But often it's easier to see those by visual observation anyway. Now, the second example, 81, negative 27, 9, negative 3, 1, negative 1/3 is also geometric. So if you're trying to find the thing that you're multiplying by to get to the next term, what I notice is I essentially divide 81 by a negative 3, right? Well, dividing by a negative 3 is the same as timesing by a negative 1/3. So times negative 1/3, and I check and see if that continues to work. If I times a negative 27 by negative 1/3, I get a positive 9. And if I times a 9 by a negative 1/3, I get a negative 3, right? And if I times a negative 3 by a negative 1/3, I get a positive 1, right? And if I times a positive 1 by a negative 1/3, again, I get a negative 1/3, right? So my r is negative 1/3. And again, if you needed a different way to find that, you could find that by doing negative 27 over 81, which is the same ratio as 9 over negative 27, which is the same ratio as negative 3 over 9, etc., dot, 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 and you get a negative 1/3, right? So again, those are both geometric sequences. We're going to walk through how to find other geometric sequences and also different formulae for geometric sequences in the rest of this section.